Okay, here's your P10, electricity and circuits. This was done really well in class, so I'll whiz through this quite quickly. Sketch a circuit with a bulb, an LDR. Let's just get my pen working. With an LDR, a variable resistor, an open switch, and it's all connected in series. So it's got to be all linked together to four 1.5 volt cells. So start with the cells, long one, short one, long one, short one, long one, short one, long one, short one. That's my 4 cells done. Now I can just go through and connect a bulb, done, a light dependent resistor, all resistors are boxes, and then I'm just going to shine light on it and put it in a circle, done. Now let's connect it to a variable resistor. Again, resistors are a box, and a variable resistor is the one that I can change using the dial, so we just put an arrow through it. I then need an open switch, make sure it's open, and then link it all together. Now, just make sure you've got no gaps in your circuits. I'm just having a quick check. You could do with a little bit of a line there. And that's good. On to the next bit. What is the potential difference used in the circuit below? So we're going to need my I'm very rich. We need Ohm's law. And then we're ready. So first job, find out the total resistance. So the total resistance is 30 ohms. And then we're ready. And we want the potential difference, V. So V equals I times R, that's going to be the 0.4 times the total resistance 30 equals 12 volts. And then we've got a mark, a mark, and a mark. Next part, it says add a voltmeter to the diagram to show how to measure the potential difference of a 20 ohm resistor. So just go through, remember ammeters go into the circuit, voltmeters measure the energy difference between 2 points of the circuit. So I just need to put a voltmeter around the 20 and make sure it's fully connected. Let's tidy that up a little bit. There we go. Done. Use the circuit below to calculate the current leaving the 3 volt battery. Always say to students, just try to, any information given in the worded bit, just move it to your diagram and we're away. So the job is work out the current flowing through there, work out the current flowing through there, and add the two together for a parallel circuit. And again, we're going to need I'm very rich, and it says calculate the current, so I want to work out I. So for that first branch, I equals V over R, 3 over 6 is 0.5 amps, done. I'm going to get a mark for that, and a mark for, no I'm not, it's only 3 marks. I've got a mark for working out that. Next row, I've got a mark for working out 2 amps, so 3 divided by 1.5 equals 2 amps, and then add the two together, 2.5 amps, done. Okay, next one, what's the power of a 3 volt bulb? So I've got volts, 4 amps, I, and it wants the power. Perfect, I can see that one. That's IP violently. So now we're ready. What is the power? And we can see P equals I times V. So P equals I times V, 3 times 4 equals 12 watts. And just make sure you're happy with that unit there. It's come up quite a few times. 4 volts potential difference, so that's V. Provided a current I, what is the resistance? Okay, no problem. It's I'm very rich again. I'm very rich. The difference is I've got to divide that by 1,000 because it's milliamps to get 0.08 amps. And now I'm away. So R equals V over I. We want to find out that. That's going to be 4 divided by 0.08. The resistance is 50 ohms. Next one, a series circuit with 2 bulbs, has a current flow of 1.2 amps and is switched on for 6 minutes. What's the total charge moved? So I'm going to need I quit. And then we're ready again. So we're after charge, total charge, yeah. So we're after Q. So Q equals I times T. Now, got to make sure we change minutes. So times by 60 is 360 seconds, but the other one's in amps. So 1.2 times 360, and I've got Q equals 432 coulombs is the unit of charge. Next one, explain why 2 bulbs connected in series are dimmer than the same bulbs connected in parallel. So model answer for this. Well, the potential difference, because we've got the same battery, the potential difference or the push to move electrons around the circuit is the same. Bulbs in series have more resistance, R1 plus R2. Well, if resistance goes up, current goes down. Now, the other way I could have explained this is if I've got two bulbs in series, I've not put it in the model answer here, they're going to share the voltage between them. They'll have a bit of volts each. If I've got two in parallel, each branch gets the full voltage, so these will be brighter. So those will be brighter than those because they have to share the voltage. So if I wanted to, I could also add that bulbs in series will share the potential difference. Okay, next one, state what the two safety features are within a plug, describe how each works. So I've got a mark for saying one is a fuse, I've got a mark for saying one is a bulb, and then describe how they work. So we've got an earth wire and a fuse, and I've taught you LRP, TTG, and then the other bits, and a fuse, TPW, M, and then we're ready to go. So the earth wire is a low resistance pathway to the ground if the metal case becomes live. So I've got a connection to the metal case. If I touch it, the current is not going to go through me. It would still rather go through the wire that's grounded because it's a lower resistance and the person is high resistance. Then the fuse, well, if the current goes too high, if there's a fault with the appliance, it's a little piece of wire that's designed to melt and it cuts the circuit. So it's a thin piece of wire that melts if the current's too high, and this then cuts the circuit so there's no risk of electrocution. And that's it. That's that one done.